This experiment is about cooling and the rates of cooling. Now you can see I've got a thermistor there held between the two crocodile clips, and I'm measuring its resistance with the multimeter connected as an ohm meter, and at the moment you see that its resistance at room temperature is between 11.8 and 11.9 ohms. Now you must remember that, so to start with we had about 11.8 ohms. Well, it's now showing 11.9, but thereabouts. What I'm going to do is to put some boiling water into the plastic jug, immerse the thermistor in it for a while. That'll be just a few tens of seconds, until the reading has reached the lowest that it will get to, and that will be the hottest that I can make my thermistor. I'm then going to take it out quickly, put it on the edge of this glass beaker and start timing. Right, let's get some hot water. When I start timing, I'm going to be able to take readings of the resistance of the thermistor every 30 seconds. And from that, we can find the temperature of the thermistor every 30 seconds using the temperature characteristics of the thermistor. Right, now it's very hot down here, so I'm going to have to do this really quickly. So thermistor in here, hot water in there, and you see the resistance is dropping, 2.3, 2.1 to 1.9, 1.8, 1.8. Right, we'll put it on there and start the clock. So already the resistance is beginning to climb. So remember, 1.8 was our starting resistance when it was in very hot water. The room temperature was actually 11.8 ohms. So we're coming up towards our first reading at 30 seconds. The thermistor is cooling down, the resistance is going up, and at 30 seconds it was 3.7 ohms. So I'll just record that, 3.7 ohms. Now I'm going to take readings for the following 7 to 8 minutes, and I will produce a table of results which will show me the change in resistance with time. And we're coming up to the next reading, which is going to be 5 ohms after 1 minute. Now, when I've got a table of resistance against time, I have also got the characteristics of the thermistor which show me the temperature against resistance. So I'm going to convert the resistance readings to temperature readings, and then we can look at how the thermistor has cooled over the period. Well, I'll just take the 1.5 minute. There we are, 6.2 ohms at 1.5 minutes. We're now going to look at the results of the cooling experiment. First of all, though, we need to consider this graph. On this graph, we show the resistance of the thermistor plotted against temperature. And I've taken these readings from the thermistor characteristics and plotted one with linear scales on both axes. And we see that at a low temperature, 20 degrees centigrade, the resistance is high and it falls away to a low value at about 90 degrees. It would have carried on, but of course we couldn't keep the water any hotter. I've then transferred that to this table of results showing the time, the resistance and the temperature. And you can see that at 0 time we had a temperature of 85 degrees, and this fell to 16 degrees after 7 minutes when the resistance had increased to 10.6 ohms. Next, we're going to look at the graph of time against temperature. This is what this one shows. And here we have it. We didn't get the very highest temperature here because it wouldn't have fitted on, and I'm very happy with this section of it. So at 0, the first point was somewhere up here, but that every half a minute we've got these readings here. I've added the first one in there because I did take one very quickly after the start. So there we have the temperature falling, not steadily, but falling down to a temperature, well, 7 minutes, we're not at 0 degrees because that is 25. And remember what the room temperature was when we started the experiment. So, as we look here, I have drawn in the rate of cooling at 4 points along the graph, and this temperature, which was about here, so a temperature of 64 degrees centigrade, we had a rate of cooling of 36.5 degrees centigrade per minute. Here at approximately 49, it had dropped to 15 degrees per minute. Here it had fallen even further to 6 degrees centigrade per minute. This is about 36 degrees, and here 2.4 degrees per minute at approximately 25 degrees. Now, of course, the rate of cooling depends on the difference in temperature between the temperature of my thermistor and room temperature. And if you remember, the room temperature we recorded with a resistance that was rather high at about 11.8 ohms. And if you look at this here, we're essentially off the scale here. So unfortunately we can't get the exact temperature, but it's less than 20 degrees centigrade. So we've got a very nice reduction in the rate of drop of temperature across the whole of our curve.